It's a pleasure to be here. So let me start out. This is always depressing. How many people have not seen the movie Risky Business? How many people have not heard of the movie Risky Business? All right, so you know it's a total age effect. So bear with me in my references to things that you have no experience with. But this is a paper that I developed with Drew Bailey, who's a cognitive psychologist at Irvine, Tyler Watts, who's a graduate student, was a graduate student now at NYU, and then Doug and Julie are developers and evaluators of a math intervention that I'll be talking about. But it's really a cautionary tale, I think, in thinking that if you have 6 data sets agreeing on something in a longitudinal study, that maybe you're approaching an idea of causation, and that was not the case for us. So let me set the stage here. This is a study that was published in 2007. It has many, many co-authors, obviously. It was a very successful study in the sense that it's generated almost 3,000 citations so far. But I want to confess that I think it reached the wrong conclusions. And it did so because it was insufficiently curious about alternative explanations for what seemed to be the emerging story. So Paul Neal is a psychologist who wrote a lot of methodology articles, and he urges you to take risky tests with your data. And I'll talk about that in a second. But specifically, it's a cautionary tale for longitudinal analyses of skill development over time. And I think it's a cautionary tale for longitudinal non-experimental work in general. So the article focuses on skill building. And for math and reading, it's pretty obvious that there's a skill building process by which early skills get built upon to produce more complicated skills. It happens in arithmetic, or it happens in math, with counting preceding addition problem solving, which is a subroutine of multiplication problem solving. With literacy, it's phonemic awareness, being the foundation for written word recognition, vocabulary, and then reading. It's a pretty obvious kind of process that takes place for literacy and numeracy. And it's been formalized in models like the one that Cunha and Heckman put together. And here, in a very stylized way, is what is going on, right? In math, there's some sort of math skill at time 1, let's say school entry, that provides a foundation for math skills at time 2 and math skills at time 3. And these paths, right, are of great interest because if those paths are really strong, then you get a pretty lockstep kind of relationship. If they're not very strong, other things happen that make early skills not very predictive of later skills. So we're going to be very interested in these paths. And in particular, we're interested in the extent to which math skill early on at school entry, if you build that up, is going to help kids 3 years later, 5 years later, 7 years later. It's a whole theory of early childhood education, really, right? That you can give kids an advantage with either academic skills or socio-emotional skills. And it presumes that in the skill building process, if you boost this early, that's going to have a strong effect on skills at the next level, skills at time 3, skills at times 4, and so forth. And the weaker these kind of connections, the less advantageous it's going to be to channel a lot of resources into building skills early on. Right? If you have questions, please raise them. All right. So in this 2007 paper, we wanted to try to assess skill building theories and answer the question, to what extent do school entry academic skills and attention skills, socio-emotional skills, relate to later child well-being? All right, and it was non-experimental, but we We're very presumptuous in saying we implement rigorous analytic methods that attempt to isolate the effect of school entry, academic, attention, and socio-emotional skills by controlling for an extensive set of prior child, family, and contextual influences that may be related to children's development, right? So we wanted to try to isolate the effects. We really were after coming as close as possible to causal impacts of these school entry skills, both academic and socio-emotional, on later school success. The analysis took place, well, it used 6 longitudinal data sets that were very similar in the sense that they all had measures of academic and attention and socio-emotional skills around the time of school entry. The British cohort study, 1970 was one of them, or 1980, is it? I can't remember. 70? They were going to do an 80, but they decided they didn't have the money for it, right? There's a Canadian study. There are a number of US studies, but they're all longitudinal. They all have large samples. They all have these measures at school entry. They're all following kids well into elementary school, and they're all measuring later academic achievement for the most part. They all have abundant information on family background, and 5 of 6 have measures of child IQ before school entry, and then all of them have measures of child behavior and temperament, right? So there's really a ton of control variables available to try to clean up whatever between child differences there might be and produce a useful estimate of the impact of these early skills on later school achievement. All right, so here's what the data look like. This is averaging across all the data sets and all the estimates of correlations and coefficients. So the average zero-order correlation with later school success, measured usually in test scores, sometimes teacher reports of how much learning kids had, were strong for school entry, reading and math skills. There was a decent correlation between attention skills. One of the, well, there are various ways of measuring attention skills. There's a hyperactivity subscale of the Achenbach Child Behavior Problem Index that was used in several of the studies, but more attention skills are associated with better school success. Kids who had so-called externalizing behavior problems, acting out, bullying, things like that, were less likely to be successful. And then pro-social skills had a positive correlation. All the kind of correlations that you'd expect. There's a lot of controversy. I mean, a kindergarten teacher in the United States, at least, will say, I don't care if kids know their letters and numbers. I want them to be able to sit still in class and become engaged in what I have to tell them, right? I can teach them the letters and numbers. So these regressions now, which control for IQ, family background, and so forth, provide some better indication of what the relative importance of these things are, right? So if you do all these regressions, so whenever you had a post-kindergarten measure of learning, that became a separate regression. You regressed it on school entry, reading, math, attention skills, externalizing behavior problems, and social skills, all the controls, right? So that's a coefficient that you get. Altogether, there are 238 of these coefficients that you can do a meta-analysis for. And this is what you get, right? Controlling for everything. So this is, you know, reading controlling for math, math controlling for reading, and everything else. You really get the early academic skills being by far most predictive of later school success. Attention skills are somewhat predictive. These are all standardized regression coefficients. But, and this was the biggest surprise, externalizing behavior problems at kindergarten are completely unpredictive of school success. Controlling for other things and social skills are unpredictive also. So the simple correlations are there, but you know, kids with externalizing behavior problems are also kids who don't know their letters and numbers, as well as kids who don't have these problems. So when you control for those things, this ends up being pretty insignificant. And there's a literature about life course evolution of behavior problems. I think what's going on here is, yes, there are kids with life course problems, externalizing kind of problems. But at kindergarten, there are many more kids who are showing behavior problems, and they haven't yet grown out of them, but they're soon to grow out of them, right? So it's very hard to pick out the 20% of kids who are initially exhibiting behavior problems who are going to be life course persistent with those behavior problems. And so when you just have the whole group, you end up not being very predictive of what happens later on. You can do this with things like completing high school, going on to college, and you get similarly insignificant results for kindergarten entry. You know, once kids are in elementary school and start to show emerging, continuing behavior problems, that's quite predictive of not finishing high school or not going on to college. But at this early point, it's not. And you know, the implications are really that trying to intervene early so that kids enter school without these kind of externalizing behavior problems may not make that much of a difference for their future school success. It's too early for that to be a reliable indicator. All right, so why is this the wrong conclusion? That's what the current paper is all about. And the answer is that kind of regression framework, even with all the controls that we had, constitute an insufficiently risky test, right? And as I say, the idea is Paul Meehl's and an alternative theory in this case, which is, yes, there is skill building, but there's also a lot of bias in these longitudinal estimates from persistent unmeasured factors that explain the data better, right? So we only considered one explanation. We didn't pit it against any sort of competing explanations. And this is, as I say, Paul Meehl's insight that when diverse theories make the same predictions, it's important to conduct risky tests that have the ability to distinguish between them. A prediction is considered risky if the probability of such a prediction being true, assuming the theory is false, is low. So in this case, it's the probability of observing large longitudinal correlations in the absence of a strong skill building process is high, not low, because there might be these alternative processes at work. All right, so what are riskier tests of this skill building model? One is random assignment, right? If you have an experimental manipulation that's increasing math skills or increasing reading skills, you can compare that to the quote-unquote causal estimates we were trying to come up with using longitudinal data. Another one is to look at the within domain patterns of correlations, early math to later math, early reading to later math, and so forth. I'll talk about that in a minute. And then finally, in one of the data sets, there are data on siblings, right? So you can compare school entry differences between siblings in their math skills, in their reading skills, in their behavior problems, and relate that to sibling differences in later school success to try to see if you get the same kind of patterns that you do if you just do it on an individual basis rather than a sibling basis. So those are the three kinds of tests that we conduct in the paper, and then compare what we get to what the longitudinal analysis showed. Again, interrupt me if you have any questions. Experimental manipulation of early skills. This is where Doug and Julie come in. We want to compare impacts of a preschool, very successful preschool math curriculum that boosted math skills by quite a bit and had follow-ups so you could see to what extent treatment and control groups differed in first grade, second grade, all the way up to fifth grade. And then compare that to the quote-unquote effect that comes out of the longitudinal analysis, right? So I don't know how many people are developmental psychologists here, but okay. So one learns in developmental psychology training that a non-experimental study can't determine causation. But then, and I'm sure this isn't the case for you, You go into the concluding section, right, the discussion section, and people make wild claims of policy implications based on results, right? And if you're making a policy implication, you're making a claim that changing policy in a particular way is going to change, in this case, child outcomes. That's a causal claim. So you can't have it both ways. You can't have you can't say, oh, no, this is not a causal analysis, and then try to draw implications. So life is too short not to aspire to causation, is one of the things I tell my students. Either think about experimental manipulation, or we need to get more serious about what to do with non-experimental data that's going to get us closer to an experimental impact. So let's take a look and see what happens if you manipulate math. This is, as I say, a nice play-based kind of math curriculum, 20 additional minutes in preschools focused on these math activities, a lot of games. Kids are having a lot of fun, but they're also learning a lot of math. There's a computer component that's not that important. And this evaluation is done in exactly the way you'd want an evaluation done, right? Cluster random assignment. In this case, in Buffalo, New York, and Boston, Massachusetts public schools. There's a treatment group, a control group, and all the proper kind of random assignment techniques were built into it. So it ran over the course of the pre-kindergarten year. If you look at impacts, controlling for where kids were at the beginning of pre-K, on math at the end of pre-K, you get an effect of 0.63 standard deviations. That's pretty big, right? The gap in Australia between math skills for the bottom and top 20% of the income distribution is about 0.8 standard deviations. Right? In the United States, it's about 1.1 standard deviation. So if you can permanently close that difference by 0.63 standard deviation with a math curriculum to low-income kids, that's a pretty big accomplishment. And moreover, if you look at subtests on this overall math test, you're getting quite respectable impacts on different components of math, right? So, maybe the 0.63, it might have come from the geometry test, and the only thing that you did was promote geometry. But in fact, it's a comprehensive test, and if you look at subscales on counting, patterning, geometry, and measurement, right, they all had significant impacts. So it's a pretty broad-based improvement in math skills. All right, so how do we relate this to what we did in our 2007 article? Well, you can certainly look at experimental impacts, but we also wanted to see what we'd get with a correlational analysis of these data, right? So to do that, forget about the treatment group. You're just trying to pretend that you've got a correlational study, non-experimental study, longitudinal study of kids' school development. So just take the control group, right, and do with the control group what we did with these 6 data sets. So the control group has pre-K math measured, kindergarten, first grade, third grade, fourth grade, fifth grade math. And you could do the same kind of regression. It's got the control variables, not quite as extensive as in the other data sets, but you can say take third grade math scores in the control group and relate them to end of pre-K math, controlling for a lot of other stuff. Right? That's essentially what we did in the 2007 article. And you can see what that coefficient is, right, on the pre-K math score. And then you can compare it to what you actually get with the experimental impacts. All right, so here's the non-experimental analysis based on the control group. If you regress the math score at age 6 on the math score a year earlier, you get a standardized coefficient of about 0.8. If you go a year later, it's about the same. If you go into 4th and then 5th grade, you're getting slight reductions here, but not very big reductions. By the end of 5th grade, you have a standardized coefficient on early math skills of about 0.4. All right, does everyone see what's going on here? These are separate regressions. In every case, you're regressing a later math score on this pre-K math score. Everything's standardized, and you're looking at the standardized coefficient, controlling for other things prior to school entry. So, you know, if you think of these as trying to approximate impacts, it should be the case that, you know, if you scale up that 0.63 to 1.0, a year later, you ought to have differences between treatment and control groups of about 0.6 standard deviations, rescaled, and that shouldn't decline very much. All right, so what actually happens? Boom. The bottom falls out after a couple of years. All right, this is one of the most disappointing findings in my, my whole academic life, I think. You know, we were so ready to see our wonderful 2007 article results reproduced in the experiment. But, you know, holds up pretty well for a year, and then it drops way down, impacts. The treatment control difference at age 7 was about 0.2 standard deviations, and, you know, barely significant. These are two standard error confidence intervals. And by the time you get out to 4th and 5th grade, you've got insignificant impacts. All right, so things don't look good for the first risky test. What about a second kind of test? This is not as definitive. But if you think about these skill building models, then, you know, math should be more predictive of later math than later reading. And early reading should be more predictive of later reading than, okay. So let's, these are data from the early childhood longitudinal study. I suspect you'd get the same thing from your child cohort studies. If you take math around the time of school entry and then relate it to later math scores all the way up to age 11, you get this kind of pattern of correlation. So these are bivariate correlations. With the 2007 article and with the control group for building blocks, we were showing regression results when you had more controls in, right? But in this case, the bivariate results show the point. So very high math-to-math correlations that kind of asymptote out at 0.7. Pretty high reading-to-reading correlations that fall to about 0.5. If you have antisocial at kindergarten related to antisocial later, you know, it's not that different from reading. So the question is, what about cross-domain patterns, right? If you have early math related to later reading and so forth. And, you know, for math predicting to antisocial behavior, you never get much of a correlation. But look about what happens if you try to predict later reading with early math, just a bivariate correlation. Starts out lower, right? The math and reading correlation is not, by definition, 1 initially. It's about 0.8 or 0.7 rather. And, you know, by age 11, you're getting almost as big a math to reading correlation as you are a math to math correlation. Math might help boost reading achievement, but it shouldn't help as much as early reading does. So this is very puzzling. And it also suggests that something else might be going on than early math skills and early reading skills. So, doesn't come out very well on that score. How about sibling difference models, right? So in this case, one data set, the NLSY in the US, follows all kids in a family, so you can pick them up when they're entering kindergarten, and you can relate sibling differences in kindergarten entry, reading and math, to later reading and math, and control for observables, but the fact that it's a sibling difference, right, means that you're also controlling for any persistent within family factor affecting children's achievement, because with sibling differences, you're focusing all the variation that you're explaining within the family. So it amounts to going beyond the observable controls and adding in what amounts to unobservable controls for everything that siblings share in a family. So similar kind of procedure. We want, in this case, to regress test scores at age 7 or 8, 9 or 10, 11 or 12 on school entry, math, and tons of control factors, and then add in controls for family fixed effects. All right, so just to remind you, this is what we'd like to end up approximating with our correlational analysis. And if you just take, without doing any sort of sibling difference, just take bivariate correlations, right? You get this similar kind of pattern that we just saw, where things fall down to about 0.6. These are math scores, and then it levels out. If you add in control variables, again, this is quite similar to the 2007 article. You get a drop, but then it kind of levels out at a lower level, about 0.35 or so. Adjusted correlations of, say, age 11 math on early math. NLSY also has a lot of unusual controls, full controls. You have the quality of the home environment, a measure of maternal cognitive ability, a lot of other measures. And if you throw those in beyond only the 8 or 10 that we used in the 2007 article, you get a further reduction down to a 0.2. And the question is, what happens if you then further control by using sibling differences? And it still continues to drop, right? So even putting in a kitchen sink for controls don't get you down to what you get when you have a sibling difference model. So that's suggestive that the 2007 article, even though it had extensive controls, might not have had extensive enough controls, right? All right, so we're not looking very good here, right? So, you know, you can always complain about omitted variables, but what about the possibility of an alternative model explaining the data better? And that's what we do in the last part of the paper. And we take a model of skill building that I talked about before, right, where you've got 3 or more observations of math as indicated by these math test scores. And then you add an unmeasured persistent factor to the model, right? With 3 or more observations on math scores, you can identify this model. It's called a latent state trait model, which is a horrible title, right? People think of it as, I mean, trait, it sounds like it's going to be genetic. But in fact, we don't know what this is. It's something that's affecting math skills at these various points in time, with these paths being identical. And we don't really know whether this is something about the child, something about the family, something about the neighborhood, right? It's just something that's having this consistent effect. If you allow for that, to what extent are these paths, these math paths from 1 to 2, 2 to 3, and so forth, going to be reduced once you account for this persistent factor? So there have been a number of studies that have estimated the state trait model. And their estimates of these paths, if you take the average size of the path, you end up with these estimates of what the average size of those paths are. Weighted average is about 0.35. So 0.35 standardized path from math skill 1 to skill 2, or time 1 to time 2, time 2 to time 3, and so forth. Now think about 0.35. Right? If this is 0.35 and this is 0.35, think about the implications for what the time 1 to time 3 adjusted correlation is going to look like. And you know, the sad thing about path coefficients is that they multiply. And if 0.35 is a respectable number, but once you multiply it by itself, which is the 2-year link between time 1 and time 3 in this case, time 1 and time 4, time 1 and time 5, right? If you don't have strong, really strong, much higher than 0.35 estimates of paths, you're going to get this decay. And in fact, you're going to get a decay pattern that actually overstates what you observe in the experiment. All right, so there have to be some questions of clarification here. Let me stop and see if everyone's on the same page here. Yeah.
Question on likely there's statisticians in the room, but how do you distinguish between latent state tray component and just error variance? From all you measures including control?
Yeah, well, random error isn't going to, it's different from allowing for this persistent factor having an identical impact at all the different time points, right? So it's, you can still allow for measurement error at each point, right? But you really want to see whether there's some common unobserved influence that's accounting for, it's not obvious that it's important, right? You could imagine a skill building process where these paths are all very strong and there's really no role for anything else, right? So it's when you allow for that, you end up with the 0.35 instead of a much higher number. So it's, it's not saying, when you see this fade out, this isn't saying that, that skill building's wrong. It's saying that skill building isn't nearly as powerful as we might have thought, given the 2007 results. You can also estimate this model from experimental data. You get a bit higher, 0.44 instead of 0.35 on the average size of the path. And if you do the 0.44 and look at its pattern of fade out, you're getting something that's, pretty darn close to what you get with the experimental results. So it's not saying this is it. It's just saying that there is this alternative model that's allowing for an unobserved set of influences that explains the experimental patterns much better than the longitudinal analysis does. So just to emphasize, we don't know what this is, and it's kind of an elegant admission of ignorance. The agenda should really be to think really hard about what that might be, to try to measure elements of it to the extent we can in the data that we gather. And then, if you measure this and control for it in the regression, right, then you ought to get longitudinal estimates that are very close to what you get with the experimental manipulation. So, a couple of caveats. To say that there's an unmeasured persistent individual or environmental factor doesn't mean that it's immutable. It's just saying it's there and it's accounting for variation in the data. It certainly doesn't rule out skill building processes. And indeed, maybe you can do something about it. Maybe there are environmental factors that suppress skill building that you can change. And indeed, this math intervention had a component that worked in pre-K, but in half the kids who did the pre-K intervention, there was a follow-on in kindergarten and first grade, right, where the teachers were taught about how to sustain the gains that kids might have learned from pre-K. So that's a way of changing the environment to try to make that fade out less, right? The more you can come in kindergarten and first grade and second grade with instruction or other kind of classroom processes that are not just allowing the control group kids to catch up because they learn a lot of math in kindergarten, but are taking the kids who already come in with skills and enabling them to stay ahead, in effect, by providing enrichment activities. So this unmeasured persistent state trait kind of factor isn't, you shouldn't throw up your hands about it, because you need to understand it and do something about it. And this booster, which had some success, if you work with kindergarten and first grade students to try to get them to understand what building blocks is trying to do, the fade out is maybe only 2/3 of what it is without the booster, so it helps a little bit, but not that much. All right, this is math. Would our results generalize to reading? I suspect so, but we need to have some reading interventions that actually follow kids beyond the end of the intervention, which isn't very common. Would it also work for antisocial behavior? We don't know. But it's interesting to think of the kind of unmeasured biases in all of the kind of skill building processes, both socio-emotional skills as well as academic skills. But it's, as I say, a cautionary tale for any sort of longitudinal analysis that you do. You can't throw up your hands and say, this is correlational. Let's not pay much attention to it. You really want to be able to say this correlational study is important, it's got policy implications, so we need to be really worried about whether the kind of lessons that we're trying to draw from our longitudinal data are indeed unbiased lessons. And so here is Tom Cruise from Risky Business, in case, I don't recommend the movie if you haven't seen it, but we've got a lot of other people to thank in addition to Tom Cruise for this paper. Thank you very much. So we've got 15 minutes, right? Yeah.
So going back to what you started earlier about like not drawing policy implications
Right.
out of the research, then what you're saying essentially is that there are no policy implications for this study.
For the 2007 study, or for the whole study?
Based on the recent analysis, that whatever was drawn from that previous study should not be taken as evidence.
I think the experimental study has a lot of policy implications, right? I think the 2007 study would lead you to the wrong, the 2007 study would lead you to think, and this is the line that I took in the 10 years since 2007 was published, that we really want to provide disadvantaged kids who are far behind when they enter kindergarten with a chance to end up more on par with higher income kids. It's sufficient to build up these academic skills in particular, and then sit back and enjoy their success, right? And I think that, which came from the correlational evidence, was the wrong conclusion. And I think with building blocks, the evidence shows it's not sufficient to boost math skills, at least in a very robust kind of way, that we need to think a lot about lining up what happens in pre-K with what happens in kindergarten and first grade and second grade. We have another paper that does kind of a taxonomy of fade out and persistence processes to think about ways of ensuring that interventions either in preschool or adolescence, prevention type interventions, for example, are as effective as they can possibly be, not only in the short run, but the long run, right? And, the skill building processes, and partly it's, this Cunha-Heckman model where if you give an early advantage to a child because skill begets skill, right? Because complicated skills are built on earlier skills. And also because if you come in with a higher set of skills, subsequent interventions, like formal schooling, for example, you'll get more out of them. That's the other kind of prediction that they have. And you know, to say that skill begets skill is to say the obvious, but just saying skill begets skill is not saying whether those paths are 0.8 or 0.2, right? And those numbers are very, very important for thinking about the sufficiency of boosting skills early. But you know, if you have if you think about prevention science for, let's say, teen pregnancy prevention, right? It's not a matter of teaching that in kindergarten and then assuming that that's going to be sufficient. It's a matter of finding windows of risk or opportunity wherever they might occur, you know, across childhood and adolescence, and then coming up with a targeted intervention that gets kids through that period of risk. You know, that's a very different way of thinking about approaching skill from a skill building process. So I'd be glad to direct you to that other paper that just got published. Yeah.
We looked at the specific program, and I was wondering whether from that we can generalize and say that the very early skills do not matter so much for later skills.
Yeah, so the question is whether, to what extent you can generalize, right, from these math skills.
Not to what extent you can generalize from a specific program.
Right. Well, you know, I'm more circumspect now about generalizations than I used to be. There are a number of early math interventions. Well, fade out is pervasive, actually, in early childhood interventions. We did a meta-analysis of evaluations, not of particular math and reading interventions, but of early childhood education programs in general. And there have been a lot of them, hundreds of them published since 1960 is when we started our search. And not that many, maybe a third, follow kids beyond the end of the program. Yeah, so one implication, if you're going to run a program, don't follow the kids after the end of the program, right? Because then you won't know the horror show of fade out. But those that do lose half of their impact within a year, and they lose half of that within another couple of years. So fade out is pervasive across early childhood education programs, and I would bet across behavior interventions. There haven't been that many with follow-ups. But again, it's not to say throw up your hands. It's to take fade out as a challenge and to think about why the kids who didn't get the intervention are catching up to the kids who did, and what you need to do to try to ensure that whatever advantage kids have, it's a little bit unfair to put it as you provide advantages to certain kids and then make sure that those advantages persist, right? That the kids who didn't get those advantages never catch up. But these are interventions, right? You really want to have implications for what should schools be doing? What's the nature of skill development that they should be engaging in? I think it has a lot of implications for teachers needing to be able to teach differentially to kids with different kinds of skills coming in, you know, both socio-emotional skills as well as academic skills. So if you've got, you know, 4 or 5 kinds of kids in terms of the math knowledge and problems that they have, equipping teachers to be able to address all 5 groups in maybe different ways to try to ensure that all of them are moving ahead. It's not something that teachers are typically trained to do, but I think differentiation is a very important thing to try to develop.
I'm just wondering about whether the persistence of these effects depends on where the child starts out. So imagine like a child who's already doing really well,
Right.
gets ahead of the curriculum, whereas at the bottom sort of helping children keep up the curriculum. I was just wondering like whether you've done that or whether there's other.
Yeah, well,
that show that.
you know, I think fade out in math is largely control group catching up, right? So, you know, kids learn a standard deviation of math over the preschool year, even if they're not in preschool, right? They learn a standard deviation in kindergarten, maybe 3/4 of a standard deviation in first grade. So kids are really learning a lot. And some of it's picked up in the classroom, some of it's picked up environmentally. Some of it's a kind of a developmental thing. They're ready to learn certain things at certain times. So a lot of this fade out, right? It's not that the building blocks kids are forgetting things, right? They're moving ahead pretty rapidly also. It's just the control group kids are moving ahead that much more rapidly. And I suspect it's because, all the kindergarten teachers, if they've got kids who already know a lot of math and kids who don't, they're going to prioritize, as they should, the kids who don't, right? So I suspect if teachers are unable to simultaneously teach to both groups, it's probably fine to have a priority on making sure the kids who don't have the skills get them. But the result then is the fade out that we observe. And I suspect there's a lot of that going on. But I think this kind of build the skill and it will just assume a life of its own is a very counterproductive in terms of policy way of thinking about it, because I think this and a lot of other evidence is pointing to the need to take very seriously what happens after the intervention's done to sustain whatever gains that you got. Yeah.
I just wanted to pick up on your point of complexity and explaining that state trait empty
Right.
state variable and other designs that could be used. So have you looked at different trajectories within group of control group and map back what are those factors that explain children who are making more rapid progress than those that are not, for example, so that we understand whether we've got these 4 or 5 groups of different children and within the data sets you're already looking at. So that would be one thing that I
Right.
would want to understand, because that would give you some explanations for what sits in that box. The other is there are a couple of very, you've used within sibling designs, but twin designs of course are tighter still. And there are data sets, so there's the TEDS UK study and the Quebec study, and I don't know whether they have particularly, they run a lot of analyses, but I don't know whether a twin design of course can give you changes in heritability as well, what that looks like. Because genetics of course is part of this story, but what genetics lets you look at is non-shared environment. And that's essentially what's in the box that we need to know. So my question is, just
Right.
asking about what's in that latent variable and what's being done to understand that.
So the first point is about latent group analysis, essentially, right?
Yes.
We haven't done that. People have done that, right? And you always get groups with different trajectories. And I've always been frustrated by that, because you really don't know what it is about the group. I mean, you can look at their characteristics, the extent to which you can measure them. I'm advising people writing a paper that does exactly this, right? They do a latent class analysis. They come up with kids who are on these different trajectories, and then look at even later achievement, right? And sure enough, the kids who are coming out with early advantages in terms of skill building are the ones who are going to end up most successful, right? But if you think about this unmeasured persistent factor, suppose it is some sort of cognitive capacity that you can't measure very well with IQ tests, and all you're picking up when you've got a latent class group that has the highest level of performance is maybe that, right? You really don't know. So yes, there are these differences, but I've had trouble understanding the implications of that for the kinds of questions that we're trying to address.
I guess the only place where that's really important is where we have observed measurement of the inputs. And of course there are some studies that do have class or whatever as a measure of the interactions.
Okay, you should send me some examples. The other point about twins, I haven't seen this done with twin studies. Maybe you have, but
I don't know if they've done it, but there's data sets available with the right data, TEPS and Quebec study, but I don't know if they've done it.
yeah, but that's an interesting. I mean, it provides some potential handle on the unmeasured factor here, but you know it's limited when you've got just this comparison between monozygotic and dizygotic twins. But it's on my list now. Yep.
I'm interested in, look, first of all, I really appreciate the rigor that you brought to this. It's really interesting for a start. I think everyone would say so. So thanks for that. The washout story, I'm thinking disadvantaged kids have multiple disadvantages, not just one disadvantage. And advantaged kids have multiple advantages, not just one.
Right.
Not just one advantage. So over time, I'm wondering if a program like this was given to advantaged children, would their multiple advantages allow them to hold on to more of that initial advantage because they have so many other things in their lives, such as perhaps educated parents with resources to assist them, perhaps they have better teachers, perhaps the overall level of skill in the classroom is higher, so the teacher doesn't have to spend a lot of their time helping a lower group within class to try and catch up to the average level or
Right.
what have you. To get a sense of that unmeasured thing that we're talking about, is because it's probably more than one thing. Let's face it, it's probably a group of things. As to what that might be, we could study the same intervention in an advantaged and disadvantaged group and watch that over time.
Yes, and it'd be nice to manipulate subsequent advantages for the kids who were, for the disadvantaged kids who were in the experiment in the first place, right? So I suspect, if you think about a kindergarten classroom in an advantaged neighborhood versus a disadvantaged neighborhood, the teacher in the advantaged school is getting kids who have all the kind of skills that the kids were getting from the building blocks treatment, right? They know their letters, they know their numbers. Parents are very supportive of the school and so forth. So what would happen, right, if after randomizing the disadvantaged kids to getting the boost versus not, you could put the kids either in an upper middle class school or the regular school that they would have gone to. I mean, in a way, this follow-on condition where you try to work with teachers to understand what building blocks is trying to do is trying to approximate that to some extent, right? So you're really trying to make kindergarten classroom processes and first grade classroom processes more like probably what upper middle class teachers have to offer.
When those kids go home, they don't have.
Right.
And other studies, I think, have shown that a lot of the success that we see for lifetime outcomes, is based on things that happen in the home as much as in the school, and the child only maybe spends 20% of their time in
Right.
school, and the rest of it's in the home environment, the local area, the extended family, whatever it may be. So those influences, I think, are at play in your unmeasured.
Right. I couldn't agree more. And finding out which ones are most important and trying to think about interventions that would approximate them, I think is very important. But I couldn't agree more. One of the things that we've discovered with US data is that advantaged families, defined as the top 20% of the income distribution, are spending on enrichment activities for their kids, things like extra classes and lessons and summer camps and things like that, $10,000 per child per year. $10,000 per child per year. That's what public schools spend on kids, right? So, I used to lament the fact that low and high income kids come in a standard deviation apart, and then in 5th grade they're still a standard deviation apart, in 10th grade maybe it's, you know, and you think, well, schools aren't really doing very much. But maybe they're doing a lot, and they're preventing the gap from increasing more and more as families keep applying the higher education levels, the $10,000 of expenditures, and things like that. So I couldn't agree more. And but really, the challenge is, you know, I'm sure a lot of that $10,000 is not well spent. A lot of it goes to the latest fads for things. But you know, what are the active ingredients in those home environments? And to what extent can we build important aspects of them into the environments that we have those kids in, right? To what extent in after-school programs, to what extent in school classrooms themselves can those advantages be?
My argument would be it's not just an education program that's required, right? In terms of an intervention, it's much more of a holistic.
Right. No, we're on the same page. Yeah.
Just on your second last slide, your last point, could you talk about
That one?
Yeah.
Okay.
So you think you shouldn't use similar constructs measured at different points in time in longitudinal models?
Well, maybe it's worry when you do, maybe is the right advice. You know, our math and literacy results, when you've got similar kind of constructs, they can be influenced by a whole bunch of different unmeasured kind of characteristics, right? And maybe it's just be cautious when you do, and always be skeptical. I mean, life is unfair because you've got journal editors and reviewers out there who want to see a p less than 0.05 and a cool theory, and you know, usually when you put in all the extra tests that I tend to put into my articles, people, oh, take that out. You know, that's clogging up the article. Just keep it simple. And you know, I think it's really the essence of what we should be doing as researchers, is being very skeptical of repeatedly subjecting our data to falsification tests, right? All the kinds of things that that we failed to do. I mean, we did a lot of things in the 2007 article, and we were very happy with ourselves. But it wasn't enough. So consider it a cautionary tale.
I think it might be a follow-on. I'm just trying to understand the size of, like, you know, you didn't really talk about like the amount explained variance, like you have tons of controls and things, tons of whatever. How much were you sort of explaining? And is that sort of like at each stage then, if you put different measures, because the amount explained or unexplained changes over time? So sort of
Right. So when I teach statistics, I say bias is everything, and explained variance almost nothing. Right? So what's important here isn't whether you have an R-score of 0.02 or 0.99. That'll influence the precision of your estimates, right? But what's really important is that those skill building paths here, are they 0.1 or are they 0.9? And what you know, in the 2007 article, we came up with coefficients on those paths that were much too high. So the key is really to think about ways of producing unbiased estimates of those skill paths. And there can be a lot of other influences going on that can be, you know, important. But if the question is, will my intervention in pre-K building particular skills advantage kids 5 years later or 10 years later, it's all about coming up with unbiased estimates of those paths. I'm sure we could continue this conversation.
I just want to make a comment before we finish, and I'm thinking about what you're saying in light of the Life Course Centre, of course. So my takeaway from this is that just focusing on early childhood is not the answer. We need to focus, it seems, on different stages of the life course where there's risk and intervene. That's a good thing for us. That's what we would argue.
Right.
But I'm also taking away that longitudinal data is not the be-all, end-all, which is what we that really what you're suggesting is that it's the RCTs, it's the experimental data that we really need to be, that's the gold standard.
Well, it's the mix. First of all, I agree completely with your initial point. And in this other paper where we talk about ways of thinking about persistence and fade out, things like prevention science. I gave this talk to a group of prevention science people. The other talk, before we had built in this other perspective, and they said, oh, it's interesting to think about skill building, which is the only thing economists think about, but we don't think about things that way, right? And the way we think about it is are these periods of opportunity and risk that come up over the life course, and the strategy of trying to develop an effective intervention at that point not to prevent people from never having kids, it's to prevent them from having kids between age 17 and 21 or 22 or later, right? So it's just a matter of getting kids through a period of risk that are pretty predictable given life course, and developing the right intervention at the right time to have that. So I agree completely that that this kind of thinking opens up the whole life course to potentially profitable interventions. Right. But the idea of the mix of experimental and non-experimental experiments are often, they've got great internal validity, but oftentimes they're done with very rarefied populations under rarefied conditions, right? And so they have some generalizability problems. I think we need more paired examples of longitudinal and experimental data to try to figure out, ideally, because longitudinal data are less expensive to collect, they're more generalizable, if you can figure out the right kind of models and the right kind of mindset going into the analysis of those data, about skepticism and falsification tests and all that, then you can hope to better approximate what the experimental impacts might be. So, I think it's a mix of data and then a lot more work trying to compare results from the two different ways of approaching things.